Hello, pre-calculus students. This is Mr. Rainsberg here for lesson 7.1, which it deals with the conic section of an ellipse. Now, what is an ellipse? You may look at it and go, well, it's an oval. But really what it is the set of all points. So the ellipse is the curve created by the set of all these points around it in a plane such that the sum of the distances from those points, so I'll pick this point xy. The sum of the distance from those points to the foci is constant. So here's one focus and here's another one. So if I take this distance, we'll call it d1, from the focus here to the point on the ellipse, I do the same thing and I'll call this d2 from this focus here to that same point. If I take d1 plus d2 and I add those numbers together, it is going to be the same distance no matter what point I pick on the ellipse. Even there, if this is going to be, we'll call it D3 and D4, two different distances. I picked another random point on the ellipse. If I add those numbers together, it's going to equal the same sum as the original. So that's what an ellipse is. So really the focus helps create the stretch around the ellipse, the eccentricity we call it around the ellipse. Now the parts of an ellipse. We have a center, we have vertices, we have co-vertices, foci, major axes, and minor axes. So we'll start off with labeling them on the picture. Now this right here, just so you can understand, is a horizontal ellipse picture. It's stretched out more horizontally than it is vertically. And the reason why that's important is because your vertices are the ones that tell you where the furthest stretch is. So if I have right here, this is what we call the center. On it, we have the vertices. Now, since it's horizontal, the vertices, each one is called a vertex, is on the horizontal stretch. The co-vertices are on the smaller stretch, which in this case would be vertical on it. So here's a co-vertex. And the foci are inside the ellipse. So here's one focus, and here's another focus. Now, if it was vertical, the vertices would be up and down, and the co-vertices would be left and right for. And we'll see a picture of that below with the formulas on it. So those are the major points around it. And notice I haven't quite talked about what is this major axis and what is this minor axis. Now, the major axis is the distance from vertex to vertex. So we'll look at highlighting it, is right here from this vertex to this vertex, that distance is the length of the major axis. The minor axis is the distance from covertex to covertex. And so if I highlight that one, this would be the distance of the minor axis. So the minor axis connects the co-vertices, the major axis connects the vertices together. It's that distance. So the major axis even tells you what type of ellipse you're dealing with, whether it's horizontal or whether you're dealing with a vertical ellipse. So let's look at the formulas. Now, here are the formulas. I encourage you to watch the video that is on the Schoology page that goes over the patterns to the formulas for it. So here's a horizontal ellipse and here's a vertical ellipse, and we'll go over them, not as much detail as that video, but just still to get the general idea behind it. The horizontal ellipse is stretched more horizontally, more eccentricity horizontally, vertical ellipse stretched more vertically. So we have our equations, and if I look at the equations, you can see there's a difference between the horizontal and the vertical. For horizontal, it says a squared is under the x. For vertical, it says a squared is under the y. So the question is, well, how do you know which one's a and which one's b when you're given an equation on it? Now, we'll kind of go through that with just the idea behind the parts. The center is hk. Now, vertices, you have your formulas. For horizontal, h plus or minus a, comma k. For vertical, h, comma k plus or minus a. Same thing with covertices, and then you have the foci. But here's what I really want to kind of focus on with these formulas. One, you have the formulas, but let's focus on just the concepts, the definitions behind it, understanding that your center is hk. And if you take a look, that is really, really important to see because each formula has an h and a k in it. Look at that for vertices, here it is for covertices, and here it is for foci. And it doesn't matter if it's vertical. Here's your hk, here's h, here's k, here's h, here's k, here's h, here's k. So everything looks like the center is the crucial starting point for graphing an ellipse. And then you go into the, well, what's A and what's B? Well, let's focus on this. A, in words, is going to be the distance from the center to a vertex, which is why A is under the X for horizontal, because these would be your vertices, and A is under the Y for the vertical, because these would be your vertices on it. That's why the A trade spots in the formulas. Now, one thing to keep in mind is, in this case, since its largest stretch is A is going to be the longest stretch, the largest denominator, because that's going to give you the furthest stretch on it. The value for B represents visually the distance from the center, because we see everything involves HK, to a covertex, which is why B is under the Y value for horizontal. These are not as far away. It's on the minor axes. It's your covertices. It's why B is under the X on a vertical, is because it's the smaller part on it. So when you're looking at an equation and you want to know, well, is it vertical or is it horizontal? Because I need to know which one's A and which one's B. The largest denominator is going to be your A squared, because it's going to give you the furthest stretch. The smallest denominator is going to be your B squared, because it's going to give you the smallest stretch, the minor axis part. Well, that leaves me with this part down here, this foci part. Well, that's not too bad. We still have, looks like an HK, so it's still going to represent the distance from the center. Now, in this case, it's going to be to a focus on it. The focus are located on the same axes as the vertices. We can see that up here as they are on the same axes on it. And so that's why horizontal, you're adding, subtracting C to your H value, because you're going left and right, and those would be your foci. But yet for vertical, you're adding, subtracting C to your K value, is because you're going up and down on it. Like I said, I encourage you to watch the video that goes over the formulas for ellipses, because it talks more about these visual patterns, moving up, down, left, right on these. Now, something else to make a note of with understanding these formulas is which axes they are on. So if I grab this, give myself some more room. If I have my A value, the A value is on the major axes, because that's where your vertices are located visually. And it's the same with your foci. The foci are on the major axes. And then for B, the covertices are on the minor axes. They are the endpoints of the minor axes. Two formulas that are not on there is the concept of major axis and minor axis before the distance from vertex to vertex, covertex to covertex, respectively. Now, major axes, if you think about it from the center, and I'll do it with horizontal, if I go to the left A units, and I go to the right A units, and that creates my vertices, the distance from here to here is twice A. And it's the same for the minor axes. and again, I'm going to use the horizontal, is if minor axis is on the co-vertices, if I add B and subtract B to create these points, the distance from here to here is twice B. And so the distance from the minor axis is twice B. That's the formulas. Like I said, watch the other video to kind of get the visual pattern down. But however, it looks like what you need are 5 values. HK, which is your starting point in a way. Everything builds off that. We saw that with the vertices formulas, co-vertices formulas, and foci formulas, is they all have that HK. That's the A value, the B value, the C value. Now to get the C value for the foci, you have C squared equals A squared minus B squared, and then you square root that value. So we're going to kind of get more ideas of these and more practice with these when we do the examples on it. And so there are 3 concepts that are going to be on your quiz for this. The first concept is identifying all parts in the ellipse and graphing. And so when you're given an equation, the first thing you want to figure out is it a horizontal or is it a vertical ellipse? And if I'm taking a look at it, what I want to do is I want to look at which one's going to have the longest stretch. Is it going to be the x value or is it going to be the y value? And so I look at the denominators. Since 9 is the biggest denominator and it's under the x, this is going to be a horizontal ellipse. And that's because the larger number is under the x. So the larger number is under the x. Therefore, that has the largest stretch, which we get our vertices from. And then I'm just going to break it down. And so the 5 values I want are my h and my k. First, I'm going to do those. I mean, my h here is 3, and my k here is -2. And so I want to identify all the parts. And here's a little table we have to fill it in. So my center is the coordinate hk. So my center is the coordinate 3, -2. And when I find it, just going to show you the visual way of graphing, I'm going to plot it. So 3, -2 right there, and I'm going to put a C so I know it's the center because there's a lot of points. And then I'm going to get to work on the other 3 values because that's 2 out of the 5. So I need 3 more. So I'm going to do A squared. I know that this is a horizontal ellipse. My A squared is under the X. So in this case, A squared is 9. Which means A is 3. Now here's Mr. Raisberg. I just know it's a horizontal ellipse, which means the vertices are horizontally from that center a distance of 3 units. So once I get A, here's what I do. I go to the center. It's horizontal, so I go to the right 1, 2, 3, and I plot a point and put a V. I go to the left 1, 2, 3. I plot a point. I put a V. Done. I have coordinates of the vertices. I can even write them. I could say it's going to be 0, -2, and I can say it's going to be 6, -2, just by counting. If you can't count, that's okay because you have the formulas. The formula for the vertices is going to be your h value, and then it's plus or minus a. So in this case, your a is 3, comma k. So comma -2. I mean, if I look at that, that's the formula for a vertex for a horizontal ellipse. H plus or minus a, comma k from the previous page. That's all I did. I added 3 to go to the right. I subtracted 3 to go to the left on it. So 3 plus 3 is 6. So I have 6, -2. 3 minus 3 is 0. I have 0, -2. So I could even use the formula. I prefer to count. And so when I have the next one, in this case, b squared is 4, so b is 2. And I understand that my y-axis, my vertical, is going to be my co-vertices on these. So I go to my center. My b value is 2. B is the distance from a center to a co-vertex. So I go up 1, 2, and I plot a point. I say CV. From the center, I go down 1, 2. I plot a point. And I say CV. There's your co-vertex. Or I can use my formula. Now, personally, I prefer the counting. So I could say this is the coordinate 3, -4. on the bottom, and it's the coordinate 3, 0 for the top covertex. But if need be, I can go to the formula sheet and I can see the covertex is h comma k plus or minus b. So I could do 3 comma negative 2 plus or minus 2. So negative 2 minus 2 is negative 4, negative 2 plus 2 is 0. I get the same idea, the same one. So you can use the formulas or you can use the visual counting. And then the last part is your foci for this. So I have my h, my k, my a, my b. It looks like I need my c. Well, c squared is a squared, which is 9, minus b squared, which is 4. So c squared is 5. So c is the square root of 5. Which, if I look at that, that's approximately 2.2. Now remember, foci are located on the same axes as your vertices. So I start at the center and I can go to the right 2.2 and I'll approximate it. Here's a focus. I can go to the left 2.2 and here's a focus. So I can plot them, and there's no harm. You have formulas. Formula says it's h plus or minus c comma k for a horizontal ellipse for the foci. So I can do for the foci 3 plus or minus, and it's the square root of 5 comma negative 2. Now in this case, what I get is I get 5.2 negative 2, and I get 0.8 negative 2. And there are my foci. Now, if I want to draw the ellipse and finish it off, I just had to think about it being oval in shape. And so I have a curve, and a curve, and a curve, and a curve. Boom. There is my ellipse. But you still have two more parts. You have your major axes, which is 2a. Well, we found a to be 3. So 2 times 3 is 6. I could even count. From vertex to vertex, it looks like it's 6 units. What about from covertex to covertex? Well, that looks like it's 4 units. Isn't that twice b? b with 2, 2 times 2. If you look at conic sections visually, it's just counting from the center. That's all those formulas are, and why I talked on the previous page how each formula has that center in there. The question is, what direction are you counting, left, right, or up, down, based off the value? But there's the first example, and we identified all the parts. If we look at the second example, I first need to figure out if this is horizontal or if this is vertical. And since the larger number is under the y, this tells me this is a vertical. Now, this is going to be helpful because in the grand scheme, that tells me my formulas. For the vertices, it's h comma k plus or minus a. For the covertices, it's h plus or minus b comma k. For your foci, it's h comma k plus or minus c. So I mean, I can look at my formula sheet right away and see I need my h, my k, my a, my b, my c, and I can plug them in these formulas and get going. So let's start that. I would say start with h and k. H is negative 4 and k is 3. And when you find it, plot it. Don't do them all at one time. Find it. Negative 4, 3 is your center, and plot it. Negative 4, 3, and put a C for center. Got it. Now we're good. We can go for our a squared. Now in this case, a squared is 25 because it is the larger number. So then a is 5. Now this is a vertical ellipse. I'm going to do them both with the formula and I'm going to do it by counting. That means my vertices are up and down. So from the center, I'm going to go up 1, 2, 3, 4, 5. That's a vertex. And I'm going to go down 1, 2, 3, 4, 5, and that's a vertex. So I'm putting these there. Or I can use my formula for it, which takes your center of negative 4 comma 3, and to that 3 value, it adds and subtracts a, which is 5. And notice I end up with the same numbers I get just from counting. If I subtract minus 5, I'm going to have negative 4 and negative 2. If I add 3 plus 5 is 8, I would have negative 4, 8, which you can see I've already plotted on it. Then you have your covertices, which is b values. So I have here b squared is 16, so b is 4. Now I can use this formula for it, or I can count from the center because covertices are on the minor axes. So from the center, my B value is 4. I'm going to go to the right. 1, 2, 3, 4, boom. CV for covertex. Left from the center. 1, 2, 3, 4, boom. CV for covertex. I could also follow the formula for it, which is going to take my -4, and it's going to add and subtract my B value, which in this case is 4, comma, keep the center, which is 3. Now let's see if I got the same ones. If I do the math algebraically with the formulas. -4 minus 4 is -8, so I should have -8, 3, which you can see I do right here. -4 plus 4 is 0, so I should have 0, 3, which you can see I do right here. So look at that. I can either count by the visual pattern, or I can use the formulas on it. So then we're left with our foci. So c squared equals a squared, 25 minus 16, so that's 9. So c is the square root of 9, which happens to be nice and easy, 3. Remember, foci are located on the same axes as your vertices. So from the center, I go up 1, 2, 3, that's a focus. I go down 1, 2, 3, and that's a focus. And look at that. So let's see if the formula works. So for focus, it's h, which is -4, my k, 3, plus or minus my c value, which is 3. So let's see if we got the same ones if I use the formula. So we have -4, 3 minus 3 is 0. Do I have that? -4, 0. There I do. And then I have -4, 3 plus 3 is 6. Do I have that? Yep, this is the coordinate 6 in the y, so that's -4, 6. And then I'm going to create my curve. Ba-boom, 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 boom. All right. Major axes is twice my a value. In this case, a was 5. 2 times 5 is 10. Minor axes is twice the b value. In this case, it's 4. 2 times 4 is 8. And I could even count. From vertex to vertex is 10. From covertex to covertex is 8. So there is our second problem for graphing. So notice the 5 values. And you can see the visual pattern I'm trying to explain, and you can use the formulas as well that I'm trying to show up here for it. So we look at the third one. Well, this one looks worse, but the concept still holds to be same. First, horizontal or vertical. The largest denominator is under the x, so it is a horizontal ellipse. Now, this is important because it tells me where to focus with my formulas. The vertices are h plus or minus a comma k. The covertices are h comma k plus or minus b. And the foci are h plus or minus c comma k. I have my formula sheet. That's where I would be looking on those. Again, it looks like the most important part is you want to always start with your h and k. So h is 2, k is 1, and when I find it, I write it down and I plot it. So my center is the coordinate 2, 1. And I'm going to plot 2, 1, and I'm going to put a c for the center on it. When I find it, I plot it. Then I find out what's my a squared. In this case, a squared is the larger one, so a squared is 169. So a is 13. So that means the distance from the center to a vertex horizontally, right here, horizontally, is going to be 13. So if I count 13 to the right of 2, I'd be right here. That'd be a vertex. If I count 13 to the left of 2, I would be right here. And that'd be a vertex. Well, let's see if that works. My formula is h, so 2, plus or minus k, plus or minus a comma k. So that'd be 2 plus or minus 13. So 2 minus 13 is -11. So I should have -11, 1, which is this point. And 2 plus 13 is 15. I should have 15, 1, which is this point. So it looks like both counting and formula work. Good for us. Then we deal with the b squared. B squared is 144. So b is 12. So that's vertical. I mean, look, it's under the y. So it's telling you, hey, move 12 units vertically. So from the center, I'm going to go up 12 units. So all the way up 12 units, boom, 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 and that's going to put me right about here. And that'd be my covertex. And I'm going to go down 12 units from the center, and that's going to put me right about here, which is a co-vertex. I'm going to plot them without using the formulas, or I could use the formulas if I wanted to. For this case, it is h, which is going to be your 2, k, which is 1, and it's plus or minus your b values, or plus or minus 12. So let's see if the formulas gets us the same coordinates. So I should have 2. 1 minus 12 is negative 11, and yep, that is what I plotted right there. And I have 2, 1 plus 12 is 13, and that is what I plotted right there. So we're good. We got them. So let's do our foci. Foci is based off your c value. C squared is a squared minus b squared. So in this case, that's 25. So c is 5. So if I take a look, foci are located on the same axes as your vertices. So 1, 2, 3, 4, 5 from the center. Here is a focus. From the center, go left. 1, 2, 3, 4, 5, and here is the other focus on it. But hey, don't take my word for it. Let's use the formula. So we have h plus or minus c comma k. Well, my c value was 5, so 2 plus or minus 5 comma k. Let's see, 2 minus 5 is negative 3. So negative 3, 1. Yep, that looks like that point. 2 plus 5 is 7, 7, 1. That looks like that point. Got them. So then we have our major axes. I can just take a look above. 2 times a, 2 times 13 is 26. My minor axis is twice b. So 2 times 12 is 24. And of course, don't forget to connect and sketch the curve on it. And so here is my ellipse. That's concept 1, identifying all the parts for it. Concept 2 takes into the idea of completing the square, and we can use that to identify certain parts that we're doing. So for concept 2, we're going to deal with kind of like the idea we did with 7-0 for completing the square. So I have, and I'll highlight them, like term, 4x squared and negative 40x. So I have a 4x squared, a minus 40x. I'm going to put together. And then I have my 9y squared and my 36y I'm going to put together. So I have plus 9y squared plus 36y. And remember, we take that 100, we move it to the other side by doing the opposite. So then that equals negative 100. So that's good so far. But the problem is we can't complete the square having that 4 in front of the x squared and having that 9 in front of the y squared. So I'm going to factor out that leading coefficient of 4. That's going to give me x squared minus 10x. And I'm going to insert my placeholder for when I do complete the square for it. And I'm going to do the same thing with the 9. I'm going to factor out, and that's a positive 9, so I'll factor out a positive 9, and that's going to give me a y squared plus 4y. And I'm going to insert the placeholder for that for when I complete the square on it. And it equals that negative 100, but I put 2 placeholders on the left side, so I had to put 2 placeholders on the right side to keep the equation balanced for it. So here we go, completing the square. So we have the general structure on it. Now let's do it. So we complete the square, we take that linear term, that negative 10x, we divide by 2, we get negative 5. I square it. That would give me a positive 25. But remember, I don't really put 25 on the right-hand side. I'm adding 25, but I'm adding 25 4 times. So really, I'm adding 100 on it. And then we do it with the y values. I have 4y, so I'm going to take that number, I'm going to divide by 2, I get 2 squared, and that's going to give me a positive 4. But I'm not really adding 4 on the right-hand side. I'm adding 9 times 4 on the right-hand side. So that's really 36. So when I complete the square, I have 4 parentheses x minus 5 parentheses squared plus 9 times the quantity y. It looks like that's a positive 2, so plus 2 squared. Negative 100 plus 100 is 0, plus 36 is 36. But remember, the standard form for an ellipse is always equal to 1. If we go look at all the previous ones and look at the formula sheet itself, the ellipse equation is always equal to 1. So I'm going to have to change that 36 into a 1. So I'm going to divide the right side by 36. Divided by the right side by 36, I have to divide each term on the left side by 36. That's going to give me x minus 5 squared over 9 plus y plus 2 squared over 4 equals 1. And there is my completing the square into the standard equation. And now we can actually find all of our parts. This is actually the same thing we did above, but no graphing, no. But we have a formula sheet, so that's good. So if I take a look at it, the largest denominator is under the x, which tells me this is a horizontal ellipse on it. So let's take a look. I have a center. I'll do the center in purple. H is 5, K is -2. So my center is 5, -2 on it. The horizontal ellipse formula says H plus or minus A comma K for your vertices. So I need A. Well, A squared is 9, which means your A is 3. So if I want to plug into the formula, I can. I can do 5 plus or minus 3 comma -2. And that would give me for my vertices on it 2, -2, and 8, -2. Co-vertices are based off of B. So B squared is 4, which means my B is 2. The formula for co-vertices is H comma K plus or minus B for horizontal ellipse. So I'm going to do 5 comma -2 plus or minus 2. So -2 minus 2 is -4. So 5 comma -4. -2 plus 2 is 0. So 5 comma 0 on it. Oh no, it asks us for major axis, minor axis. Well, that's okay because major axis formula is twice A and minor axis formula is twice B, and we've already found those values on it. A is 3, so this is going to be 2 times 3, which is 6. B is 2, so 2 times 2, which is going to be 4. I don't need to graph to identify certain parts. This is concept 2 on the quiz. Complete a square and identifying important parts from that. So let's take a look at this one. Same idea, like terms together. So I'm going to highlight again. I'm going to get my like terms, 16x squared and a 128x. Those numbers are going to go together. So I have 16x squared plus 128x. I'm going to highlight the y term. So y squared and -18y. So y squared, so positive y squared, minus 18y. And that equals -273. Well, I cannot complete the square with that 16, so I'm going to factor that out. So 16x squared looks like 128 divided by 16 is 8. And I'm going to insert my placeholder there for when I complete the square on it. I do not have to complete the square. Well, I had to complete the square, but I don't have to take anything out of that y. The y is actually all by itself, so I don't have to factor anything out. I can just leave it there and put the placeholder. But if I put the placeholders on the left side, I have to put the placeholders on the right side to keep the equation balanced. So it does equal -273, but I'm going to put my blue placeholder for the x term, and I'm going to put my green placeholder for the y term. Now I can complete the square. So I'm going to take 8. I'm going to divide by 2, which is 4. 4 squared is 16, so a positive 16. But remember, I'm not really adding 16 to the right-hand side. I'm adding 16 times, which is a positive 256. And then when I complete the square over here, -18 divided by 2 is -9, square it, that's going to give me an 81, a positive 81. There is nothing that I have to worry about there, so I am going to put a positive 81 here. So now when I complete the square, I have 16, looks like quantity x, and it's plus 4, plus nothing out here, so just the y, and that looks like it's a -9 squared. And -273 plus 256 plus 81 gives me a 64. But again, the equation for a conic section for an ellipse is equal to 1. So I have to divide by 64. If I do that on the right side, I have to divide everything on the left side, all the terms, by 64. And that's going to give me x plus 4 squared. On the bottom here would be a 4 plus y minus 9 squared. That stays at 64 equals 1. There's your standard form equation from completing the square. Now, is it vertical or is it horizontal? And I can see that the largest denominator is under the y, so this is a vertical ellipse. Now, that's helpful because that tells me that 64 is my a squared, and it tells me that 4 is my b squared on it. And I'll try and keep the color coding of vertices and co-vertices. So vertices were blue. So a squared is 64 and b squared is 4. Well, what's my center? That's an easy question because your center is your h and k. H is -4, k is 9. So my center is -4, 9. Now this one's not straightforward on what's your vertices. It's asking you what's your foci. Well, your foci for a vertical ellipse, if I look at my formula sheet, is going to be h comma k plus or minus c. That is the formula for the foci. Now, the problem that we have here is I have a squared, I have b squared, but I need c for the foci. So remember, c squared is your a squared minus your b squared. So c squared is 60. So c is the square root of 60 for it. Which, if you look at that, we can look at it as the approximate, or we can simplify the radical for it, which is around 2 square root of 15. As a decimal, that's about 7.7. So I have my formula. It is h comma k plus or minus c for a vertical ellipse. So it's going to be -4 on it. And I'm going to have, and I'll do this, I'm going to have -4 comma 9 plus or minus c, so plus or minus 2 radical 15, which I can even just write down as -4, 9 plus or minus 7.7. But man, wonder if there's a reason why Mr. Ransberg was writing that simplified radical. I don't know, maybe it's important for something in the future. So I have -4 comma 1.3 and then -4 comma 16.7. There's your foci using the formula. Now, if I want to find my major axes, I actually have to know A. So square root of 64 is 8. So major axis is 2 times A, 2 times 8 is 16. The minor axis is twice B, and in this case, B is 2. So twice B, twice 2 is 4. So that's all the parts. So concept 2 on your quiz is being able to complete the square to the ellipse standard form and use that with the formulas to identify the parts. Concept 3 is writing the equation when you're given certain information for an ellipse on it. So concept 3 is, notice we don't have an equation. All we have are the parts. So I'm giving you parts, you have to figure everything else out. So if I take a look at this, what I want to do is I want to see what I'm given. Vertices are located at 8, -6, and 8, 10. So when I'm dealing with this, maybe I want to draw a picture for it. If I draw my picture, it doesn't have to be to scale. So here's my y-axis, here's my x-axis, and I just plot the point. Here is 8, here is 10. This is a vertex. And then 8, -6 is the other vertex. So right away, just so you can see, that tells me that this is a vertical ellipse because my vertices are up and down. So that tells me I have a vertical ellipse. Why is this important? Because I'm asked to write the equation of the ellipse. So the equation for a vertical ellipse is x minus h squared over b squared plus y minus k squared over a squared equals 1. So again, I still need a, b, h, and k on it. Now, how is this helpful? Well, if you think about it, I'm giving you the 2 endpoints of the major axes, which means somewhere in this vicinity on it is going to be your center, somewhere around here. And really, your center is the midpoint of the vertices. This is the midpoint of the co-vertices. This is the midpoint of the foci. The center is the midpoint of those important parts. So to take the middle of them, I just add 8 plus 8, my x-coordinates, divide by 2, and I add my y-coordinates, negative 6 plus 10, and divide by 2. So my center is the coordinate 8, 2. That is my center. That gives me HK. I mean, look at this. I now know it's x minus 8 squared. I have no idea what b squared is, though. I have y minus 2 squared. I don't know what a squared is, though. Equals, I'm really only missing 2 things now. I really have like half my answer there. Well, I know what a is. A is the distance from the center to the vertex. I mean, that's a. And my center is the coordinate 8, 2. So if I'm looking at this, if I'm saying, you know what, from the center to the vertex is the value a. Well, in that case, a from 2 to 10 is 8 units, which means a squared is 64. So boom, 64. That wasn't too bad. The counting pattern, it's the visual pattern on it. What about your co-vertices? If I have my co-vertices at 11, 2, and 5, 2, let's plot them. So it doesn't matter scale. Here's 11, 2. This is a co-vertex. Here's 5, 2. Well, how does that help us? Well, the distance from the center to a co-vertex is b. So hold on, how far away is 8 from 11? That's 3 units. So in this case, b is 3. So then b squared is 9. Well, there's our equation for the ellipse. So it looks like that understanding the formulas, visually what is A, visually what is B, visually what is C is really, really important. If I look at number 7, it's telling us that the major axis, these are vertices, the major axis is 16 units long and it's parallel to the x-axis. Now, why is that important? Well, if it's parallel to the x-axis, that's telling us that this is a horizontal ellipse. Again, well, why do we need to know if it's horizontal or vertical? Because you need to know what your goal is. And the goal for horizontal ellipse is for the a squared to be under the x minus h, and for the b squared to be under the y minus k. So that's my goal. I want to write that formula down. Now, how is this helpful? Well, let's figure it out. If I know my major axis is 16 units, I mean, your major axis twice a is 16. I know a is 8. Well, man, I know this right away then, don't I? I know a squared is 64. Well, what else do I know right away? Well, right away, I also know my h and my k. I'm told right there. My center is 5, 4, so there's my h and there's my k. So, I mean, boom, h, k. So the question is, how do I find my b squared? Because I got everything else so far. Let's figure it out. Well, it says my minor axis is 10 units long. Well, my minor axis is 2b, so 2b equals 10, so b is 5. Well, and then I know b squared. B squared is 25. So I know this. I have x minus 5 squared over a squared, which is 64, plus y minus 4 squared over b squared, which is 25, equals 1. I have the equation. Look at that. Use the formulas, figure them out, help them out. The endpoints of major axes are at 10, 2 and negative 8, 2. And the foci are at 6, 2 and negative 4, 2. Well, you know what? I'm going to draw a picture. I really strongly believe in visualizing what you're working with. Here is my picture. And it says the endpoints of the major axis is at 10, 2. Again, scale doesn't matter. And endpoints of major axes are vertices. And at negative 8, 2. So these are my vertices. And I label them because that tells me this is a horizontal ellipse because my vertices are left and right of each other. Well, that's helpful because that tells you what am I aiming for. I'm aiming for the a squared to be under the x minus h. I'm aiming for the b squared to be under the y minus k. Well, if I can give my endpoints, I can find my center on it because your center is your midpoint. So then I have, take the x's and add them. So plus negatives and minus. So 10 minus 8 divided by 2. 2 plus 2 divided by 2. And my center is the coordinate 1, 2. And by the way, you can even count on it if you don't want to use the midpoint formula. So 1, 2, that is my center, which means this is my h and this is my k. So I now know x minus 1 squared. I don't know what goes in the bottom. I know y. Rewrite that plus sign 100 times. Let's just erase and do it again. Y minus 2 squared. I don't know what it's underneath yet. Equals 1. Figure out a and b. Because a is the distance from center to vertex. So from 1 to 10 is 9. So if a is 9, a squared is 81. And boom. So it looks like all I need now is the b squared. That's not bad. What else am I given? I haven't used that last part. The foci, oh no, foci are at 6, 2 and negative 4, 2. So here's 6, 2. That's a focus. And here's negative 4, 2. That's the other focus. Now, how is that helpful? That doesn't give me B. Focus is my C value. The distance from the center to a focus is C. So from 1 to 6 is 5. So my C value is 5, which means C squared is 25. So does that mean 25 goes here? No. Formula asks for B squared. Well, how do I find B squared? It's all about the formula sheet. We know C squared is A squared minus B squared. So 25 equals 81 minus some number. So then B squared would be 81 minus 25. So B squared is 56. So always have that formula sheet out. Always go through and look at it. But above all, if you ever need to find something, you can go to the formulas. But I strongly, strongly believe it is important for all of you to understand what each letter visually means. What does A mean? What does B mean? What does C mean? So this is the lesson for ellipses. If you have any questions, please feel free to reach out.